So this is lesson 3.5. We're looking at solving systems of 3 variable equations. Now, in elimination, if there were just 2 variables, there would only be 2 equations, and we would just try to eliminate x or y and plug it in to get the other one. Solving systems with 2 variables should be something that's pretty familiar to you. With 3 variables, though, it's a little bit more complicated. So you want to start by building a smaller system if possible. So we're actually going to do elimination twice to try to get rid of 1 variable. So here's my first step. Which variable's new to you? Z. All right, please make sure you're paying attention and not catching your z's throughout this lesson. We're going to, using these 2 equations and using the bottom 2 equations, you could come up with another combination. I could do the top and bottom one, but I'm choosing to do top and bottom middle for this. Step 1 is to create a system where z is eliminated. Create a smaller system, a system within the system, where z has been eliminated. Because if I have a system that has only x and y, we're really good at solving those systems. If you know your answer for x and y, could you find z? What would you do with x and y? Just plug them in, and then all you have is a 1 variable equation. So looking at so I'm going to ignore, let me cover it up. It won't be completely covered, but we'll pretend it's not there. We're looking at just the top 2 equations, and I want to eliminate z. How am I going to get them to be opposites? They already are. Awesome. So since they're already opposites, that gives me the following system when I add them. So I'm going to add those 2. I'll write it out so you can see it. This is x minus 2y plus z equals 15, and 2x plus 3y minus z equals 7. I'm going to add them up vertically. Z goes bye-bye. We are left with 22 on the right-hand side of our equation, 3x plus y on the left-hand side of the equation. This is part of our system within the system, part of our smaller system. But I have 2 variables here, so how many equations do I need to solve a system with 2 variables? 2. So I'm going to now look at these bottom 2 equations. I'll do that in blue. What do I need to multiply to get the z's to be opposites? -5 to that middle equation. So by multiplying the middle equation by -5, I end up with -10x minus 15y plus 5z, equals -35. It's running into the other thing, sorry. -10x minus 15y plus 5z equals -35. The other equation already has the -5z, so I just copy that one down. Now we're going to add them up. So when I add these vertically, I'm left with -6x minus 5y, the z's went away, equals -38. So using the top 2 equations, we did elimination of z to get this equation. Using the bottom 2 equations, we used elimination to get rid of z, and we are left with this. We now have a smaller system of equations. We can choose to either make the x's or y's negative. What would you guys prefer? You want to make x's? So what do I need to multiply this equation, since this one is already the opposite of 6x? I need to multiply this one by 2 to make that 6x. So no, you want it to be positive since that's already negative. That's going to give me 6x plus 2y equals 44. Questions on that? So we're kind of ignoring the rest of the problem. This is its own systems problem within the system. And we have multiplied by 2 to make the x's opposites. I could have just as easily multiplied by 5 to make the y's opposites, but that's more work. So I'm going to add the equations together. The x's go away. We're left with negative 3y equals 6. Because 44 and negative 38 add to 6. Or 44 minus 38 is 6. Divide by negative 3. Y is negative 2. But that's only a third of our answer. Within this system, within the subsystem, it's half the answer. What am I going to do to find x? Plug it back in. I'm going to go with that equation. I got 3x plus negative 2 equals 22. So that's 3x equals 24, which gives me x equals 8. Now I have 2/3 of my overall system solved. The subsystem is completely solved. How am I going to find z? Plug in x and y to any of the 3 original equations. So once you have solved the subsystem, plug it back in to get the last variable. My handwriting's amazing, isn't it? Sorry. Plug it back in to get the last variable. So the equation up top is x minus 2y plus z is 15. That looks like the easiest one for me to plug it in. So my x is 8 minus 2 times negative 2 plus z equals 15. So that actually is positive 4. 8 and 4 adds to 12, which means z is 3. As an ordered pair, oh wait, it's not an ordered pair because it's not 2-dimensional coordinate plane. It's 3-dimensional, so it's an ordered triple. We have 8, negative 2, 3, representing x, y, z coordinates in alphabetical order. Yes, sir. So see the system of equations we have right here. 3x plus y equals 22, negative 6x minus 5y equals negative 38 that we got by eliminating z. We chose, you guys said to make x's. You wanted to make x be eliminated. So I multiplied this equation by 2, giving me 6x plus 2y equals 44. And then I was able to eliminate x to solve for y. Try this for letter B, but I don't want you, like somebody in my last class said, well, Mr. Ritter, can't I eliminate x? X looks easy to eliminate. You can eliminate any variable you want. But since we're comparing and I don't want you to get too far ahead with making errors, I'd like you to start by eliminating z first. We're going to make it easy. We're going to eliminate z first. So if you could do that and just build your subsystem over here with the x and y, do that first so that I can see what your subsystem is and we can make sure we're on the right path. All right, so for this one, for the top 2 equations, I multiplied the top equation by 2 because that was a negative 2z. And then when I added those 2 equations together, this is what I got. X plus 3y equals 5. For the bottom 2 equations, I wanted to eliminate z. That's a negative 2z, so I multiplied everything in this equation by 2, giving me this equation. When I added them, I got 5x minus 3y equals 11. So this is the system that you guys got in class. And now, what's nice is this is already set up for elimination. You don't need to do any multiplication at all. Why? Why is it set up so nicely? The y's are already opposites. So by adding these 2 together, I've got 6x equals negative 6, because the y is eliminated, giving us x equals negative 1. What am I going to do with that negative 1? Plug it back into one of those equations. I'm going to pick this one right here, the top one in pink. Plus 3y equals 5. So when I add 1, 3y equals 6, giving me y equals 2. Now I'm going to go back to the original system that we eliminated z from, because that was easy. And we're just going to plug in x and y and solve for z. So -1 plus 2 plus z equals 5. That's going to be 1 plus z equals 5, so z equals 4. As an ordered triple, this is -1, 2, 4. Any questions on solving 3 variable systems using this method? Doesn't have to be z that you eliminate first. It's what I chose to for both of these, or asked you to do for both of these. But you could choose to eliminate x or y first if you wanted to.